clip, everybody's like,
why don't we ever play musical?
Get some music going.
what music?
Yeah.
Jordan?
Latimer missed last class.
Am I that boring?
We watched NASCAR. Dude, where's that NASCAR video? We watched Mythbusters and NASCAR. We need to learn.
And the
Let's watch like the back to learn about Dale Earnhardt. Let's watch clips of Mythbusters. It's so funny he like narrates it. He's like, and you think he's looking at his friend. He's looking at Dale Earnhardt Jr. The student came in that class, that's like the supervisor in the back. And Latimer was like, my supervisor's coming in today. But you know what? I've been teaching here 40 years. We're going to do the same exact thing. We're going to watch NASCAR.
Yeah, like, that became the primary focus of the show.
I see no fascination with NASCAR. Cars going around in a circle.
draft.
Once you go around once, you've seen everything.
Chip it on board.
I know, but I
Sometimes they crash too.
Yeah, but Dale Earnhardt Jr. crashed.
Beside Latimer, I had a friend of mine.
Most
I had a friend of mine who was so into
was
this.
Junior.
She just sat and I didn't think women were so
Go watch
into
the
this.
video
She
and
would just
watch
watch that and watch it, and I would go, how could you sit there?
Maybe she's
You know
doing
what?
that.
That's
That's
fine.
why
You
we
really-
want exercise.
You know what I think?
No, this woman have to brain cells. The truth is that
That's the
wrong.
crash every like 100 rounds.
Then again, she did have a lot of teeth.
Formula One is exciting.
No.
You watch Formula
Yeah, they
One
can script
racing,
it.
that's
Yeah.
exciting.
Yeah. The best
You're gonna die on the tires.
I'm telling you, it's the rally car races, the X Games, where they have like ramps and they're like jumping over each other and they're like smashing into each other, and that's cool. And it's like 3 laps and they're done, so it's just like an all out. They're just
Yeah, if it was like 10 laps, I can get behind that. 200,
people are
Yeah,
dying.
no.
It loses the value.
This is a crash every 40 laps. And it's
That guy
scripted.
died. What's going on later?
It's like you're gonna die tomorrow, you're gonna lose your leg.
He was in first.
You're gonna.
No, but
On lap number
Jimmy,
38.
like, the guy was
Sorry about
finishing
this,
the
but
race
you're not
with
going to
a
make
door
it
on
past
his
lap
car.
You're
45.
going to
Like,
fly into the
that's so
stands,
cool.
wipe out the whole first couple rows. Highest rated race ever. Okay? Take one for the team here.
That's so much better than
It's fun to watch. It's like Formula 4.
Ricky, I'm going to need you to jump into the stands.
Formula 4.
Ricky, I'm gonna need you to exit your
Ram.
vehicle and run into an oncoming car.
A pyramid with a horizontal square base.
What did you color is
Bobby
it?
NASCAR, I would watch it.
Yeah. So Formula 1 cars will be a lot.
Pants are on fire!
well, it's speed or like hard stick.
There's like a very specific set of what you can use.
I feel like I can put a speed limit on
Formula 1 cars.
purpose.
Formula 4 cars are
Go 40 miles an hour.
40 cars. So you buy
They're the police cars.
I'll be taking notes in the thing.
No raps as always possible.
4 meters?
Do you agree? Yeah, I agree. Good, we're seeing the same color.
Cause all Chinese people jump up and down at the same time.
Now this problem looks difficult, but it's actually extremely simple if you pick up on something. The reason I'm giving it to you is to see how intuitive you are in the idea of something.
Oh, okay.
Was I big enough?
Yeah.
Circular field.
This will be the last thing you probably do before you move on to the spherical symmetry stuff. Why would you say that? Okay, so you're saying that just finding the flux through the square base would be the equivalent of finding it through the four slanted sides. And give your rationale again? Another one's rationale.
Because when you're looking at it,
It's Carter's ears.
area, It seems because the same amount of lines in and the same amount of lines out on 4 sides. Like,
You have to put your two answers together, and that gives you the correct answer, the correct explanation.
Every line that enters the base comes out through a slanted side.
Right.
that, I feel like that's
So-
the whole answer.
So how do you calculate it?
52 equals 52.
No, how do we calculate it?
52?
But-
You
but-
don't
but-
have to.
Yeah, well, yeah, no, you do have to.
52 over
We
E9.
want to get the flux.
52 over E9.
But just want the flux. The flux.
52 over E9. That's a field.
Look at your formulas, look at your formulas, look at your formulas, look at your formulas. There's not that many of them.
52 equals Q.
The integral of EDF.
Huh?
The integral of EDF.
The integral
Surface
of,
integral of EDF.
or EDA,
Sure.
okay, which equals what?
Surface integral of 52 dA.
Okay.
What's that first? Oh, 36? 36? Wait,
The math is,
is that all it is?
yeah, would you want
It's just,
to
you didn't do
That's
I
all it
don't
is.
know. You didn't integrate it.
It seems like there's substantially less calculus there.
Yeah.
Where did the integral go?
Where's the constant?
Where'd the integral go? What's the
What I'm
constant integration?
assuming he understood was that, and the cosine is actually 0. Okay. So basically it's EA, and the only thing
As long as you
that
understand that.
John did was did this.
We just need to know the situation.
I'm assuming you can just do the math. But it was
It
52
gives you the right units, I don't know.
Yeah,
Why does the surface integral equal EA cosine?
because it's a dot product. Remember, this is a dot product.
Right, but there's still an integral. You just,
where the
But
integral.
these are all equivalent statements. Flux is this.
Oh.
so why did
Anytime
you
you're
go?
going to use the integrals, if you actually are given a formula.
What angle
you
is
can use
zero?
this.
Yeah, what's the
Okay.
What angle are you looking at? Like,
Huh?
what
It
angle are you
enters
looking at?
That's a nice formula.
It enters
horizontal plane.
Remember the
Plus
angle.
90 degrees. It enters at 90 degrees.
Right
Remember
now,
that angle,
no.
the angle of the field with respect to the DA element?
EA is this.
The DA element?
Oh, okay,
Yeah, remember that? So that's what you do. So what is 52 times 36?
1872.
1872.
1872. Okay.
I guess you did kind of tell us that.
All right. That problem can be really looked at difficult if you didn't see what you two guys saw. That's why I'm making a mistake.
We don't need boxes.
Millimeters.
Meters.
Terrible. So as a box formula, flux equals the dot product of EA?
Yes. Again, the integration, you're very rarely going to use in and of itself unless you have a formula that's given. Okay? Again, how many of you saw it? How many of you actually saw that? Did you recognize that? Okay, what were the rest of you going to do?
Wait for Jason to get it.
No, if it was on the test, what were the rest of you going to do? That's the other option. That's much more tedious.
The first thing that I thought
That's the only
was
thing you could do.
there's no Q inside the pyramid, so it's got to be 0. But then I started thinking about the field lines.
Just notice that the units are units per coulomb. I was just gonna multiply by the area. They didn't do units per coulomb.
Hey, if it works for you.
That's what I honestly.
It's
I was
all
thinking
about
the
the
same thing.
unit game.
I was looking at it, I was like,
There we
what
go.
units? Okay.
See, I
if you
don't, I
need
don't know.
millimeters
I don't know
per
the units
coulomb.
for any unit. You should probably pay attention.
Yeah.
Units, like,
I never paid attention.
I need a voltmeter. How do I get a voltmeter?
wait, literally just give my answer.
Okay, we're doing
I just look at
You don't need units, you can't be wrong.
You gotta be a robo-light to be into units. A robo-light. A robo-light, that's my new name for robo-light.
I like
Sounds like a song.
The
Robolian.
the
A
robo.
robogolian, is that what?
Robodonian.
I said Robolonians.
What does he do when he does his element problem? Rebodium? He does his, I don't know, when he teaches, I guess those you didn't have one, that's right, you wouldn't have had it, because he does it in Chem 271. When he does his examples for the atom, and he has to do protons, electrons, and neutrons, he goes, there's a new element that was discovered on the periodic, I've said to this lecture so many times I've memorized it. There's a new element on the periodic table, look, and he goes, it's rebodium.
Like half the kids probably.
And the 271 kids go, really, where? It's down there. He just makes up fake electrons and protons. Okay. So,
You find this in you and me.
It's got 15 protons, 236 neutrons, and 7 electrons.
Wait a minute.
spherical symmetry. We're
And it's
gonna
also
look at
vaguely donut-shaped.
Spherical symmetry. Okay. So here we go. There we go. This is Mr. Maniglia's easy methods of doing stuff. Case 1.
Carter.
Keep these notes, bronze them, sell them to your friends in college.
That's not
$10 a letter.
He told us we weren't allowed to sell the nuts.
Yeah.
We should do it, yeah, but if you do it $10 a letter and give Mr. Beniglia 10%.
Well, the funny thing is, in my graduate course, we had to do a discussion board thing, and I did it on Creative, I don't know, do you know what Creative Commons is? Okay, the ability to copyright stuff and give people rights to it. So I said, oh, Creative Commons is a great thing, but my professor loved it. So I says, yeah, except for me, where my stuff was ripped off by, a student and sold, but with the full knowledge of a college professor, and she writes back, what a horrible thing to have to go through, Ron, and blah, 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 college. I didn't have the heart to tell her it was Drexel University where it happened. One of my students went to Drexel, and the Drexel physics professor was the one that had knowledge that the kid was selling in the class, actually told the class to go on the website and get the notes. And I didn't tell her that it was Drexel, because otherwise she would have flipped out. So, just a little point of interest. So, anyway, all right, so we have a charge Q. Yay, Q. Is Q nice? Do you like Q?
No.
I feel like I'm about to nod.
Okay, all right.
Dude, him and a lady. were
Q is
talking to-
positive, what did you
talking to
tell
a funny
me?
joke.
Lines go out.
Lines go out.
No. You probably told her she had a tree.
Everybody good?
Well, you're clearly not a tree. It's pretty funny.
I'm going to draw a imaginary
Thank you.
spherical Gaussian surface around that charge. Okay. By the way, the abbreviation for Gaussian surface, if you didn't guess, is GS, Gaussian surface. They were very creative in making this stuff up. Okay. And of course, we'll put it at a distance R from the Gaussian surface. Now, if that electric field is uniform, okay, evenly distributed, and everything is nice, what could you tell me? What could you tell me about the angle between the area element of the Gaussian surface, the electric field lines itself? What should those two be?
Parallel.
Parallel. They should be parallel to each other. Would you agree to that?
I missed what you were saying.
You okay, Carter?
I thought you were talking about the outside of the Gaussian surface. I don't know, area.
What's the area element?
So provided this is a uniform charge distribution. Okay. We can say that the area vector dA is going to be parallel to the electric field lines. Everybody good so far? Yes, no, maybe? Okay. So we know the definition of flux is the integral of the closed surface E dot dA.
Charge distribution one.
We know that, correct? Yes, no, maybe?
Is that DA?
Yes, that was mentioned.
That's, let's be over there.
No. Is that DA next
Yeah.
to
This is
perpendicular?
DA.
Yes, that's DA parallel to electric field.
Okay.
Those wonderful markers. Okay. Okay. And we know from yesterday that this equals Q enclosed over epsilon CC. Which means that since it's a dot product, We've established the cosine being 0. This is EA equals Q enclosed over epsilon sub 0. Okay? We're talking about a spherical surface. What is the area for a spherical surface?
4 pi r squared.
Very good, 4 pi r squared. Any good so far? Yes, no, maybe? Okay. What is epsilon sub 0? Not the numerical value, by the way.
1/4 pi k.
Everybody good so far? Yes, no, maybe? Solve that for E.
E equals QK over R squared.
Q R squared.
Oh my god! You just did it.
You just derived Coulomb's law from Gauss.
I can feel
So, what is the electric field measured from a Gaussian surface from a point charge using spherical symmetry? Coulomb's law. Q over R squared.
Wow.
Yes.
What came first, Gauss?
That was their step yesterday. Actually, Coulomb, and I checked it out. Coulomb came first historically, then Gauss. Okay. Carl Friedrich Gauss. What is his name?
So did he work backwards from Coulomb's law? Or he just get lucky?
Gauss doesn't get luck.
He looked up the answer key in the back of the physics book of the 1800s.
It's told
Only the odds.
Okay. All right.
Only the odds.
He's a time traveler.
He's a time
He had to
traveler.
answer the email.
He's actually someone in this
You might see that on Yahoo News. They said they found a time machine out in the desert. Genius. I don't believe it. I want, where's the picture? Where is the picture?
The Stargate. It's the
This
Stargate.
is Stargate.
to learn my own work.
The other thing that was a little scary is the exiting guy who was in charge of Homeland Security for the United States.
Teaching, teaching me.
When he went out, this guy believes in UFOs. He has been trying to get the government to release the UFO files, and I don't know how he got away with this, and he's been bugging Obama to release it. The public needs to know. Well, now that he's out, he's saying that there really were aliens that landed, and he doesn't think the public would be, shocked to know that this has happened. He just wished the government would release the information. Like, I think this guy's going to be gone in a couple of weeks. You're going to see him. They'll be like, where is he?
Did he ever really?
Don't think it was a smart idea to be speculating.
He really wanted to know there are other ways. He really wanted to know if there's UFOs.
Well, when I was growing up, Roswell was a big thing. One of the things they were saying is the fact that if you believe in UFO conspiracies is that both the Soviet Union and the United States knew it was true. They both had alien captures, but they didn't feel the world could handle the knowledge, the fact that
I agree.
aliens. Basically, the other part of the rumor was that a lot of the stuff that they were inventing, like the jump from transistors to chips, is quite a big jump to make. Well, the rumor going around during that time is that they had actually gotten alien technology and reverse engineered it.
That's my thing. Is like you watch the show Ancient Aliens, and it's the same thing as saying that.
Right.
They said every major human advancement was by aliens.
Right.
Which I'm giving ourselves a little bit more credit than that. I think we did some stuff on our own.
Like the Model T ads.
We went away from our first power to space 65 years.
That's the
But it
only
followed
ones.
a trend curve of
Unless
exponential
aliens are
growth.
selling us
It
information.
would have been a line book.
Obama.
Oh, it was also in the news last week that life on this
Aliens
planet, they
invented
found a metal disc. Did
parabolic
you see that in the news?
No.
They found some metal disc somewhere in some dig, and they said that they're speculating, they don't know where this disc came from. God knows where it is. forged, and some, they're saying that this may have been sent from aliens to populate the world with,
The
us.
manhole
Other
You know,
discs.
you know.
You know, I think it's more interesting, like when we send
The
stuff into
disc race
space,
is coming.
if it's not
They're gonna play
sanitized,
Frisbee
it
with
has
us.
organisms on it, we can put life on other planets.
Oh, yeah.
I think that's,
Well, you weren't alive, but when they came back from the moon for,
they were.
if you saw it, they put them in an Airstream trailer, modified Airstream trailer for weeks and weeks and weeks, because they weren't sure.
See, I find that more
You know, well, the other thing that's
Yeah,
interesting,
yeah,
when
yeah.
when they did all sorts of studies on the moon, you probably don't know this, they never knew if the moon was actually, how solid it was. When Neil Armstrong went off that thing, if you actually watch the video carefully, he doesn't quite let go, because they figured, you know, they didn't know if it was like soft, I mean, they would have went right through.
I think he
That
knew
would have
when
been
he
one
started
small step,
Hollywood.
one
small step.
Son of a
Their lunar lander was already rusting.
What if it was like a marshmallow and the lander just kept going in?
I guess they just fly back to Earth. They'd be like,
Just
all
like
right, well, that
sinks
sucks.
into it.
Have you
Like,
been to the
Right
Museum
through
of
the moon.
Science
It's all
and Washington,
hologram
D.C.,
projector.
He's sinking in the cheese.
backup lander that they use? That thing is made like out of paper mache. I mean, because it was never meant to really be in Earth's gravity per se. It was outer space. I mean, the thing is like, they said you literally could put your hand through that thing.
What?
Some kid put his hand through it.
It wasn't meant to do anything major.
Smashed the window and the hand was just bleeding everywhere.
Case number
I have no
two.
idea. I don't know.
What was case number two? Oh, a spear, a solid
Somebody
spear.
just smashed the window.
We need a point charge. Come on, keep up.
Oh,
Good try. Okay, so we're gonna, this one gets a little bit more tricky.
shit, Jerry.
Oh, that's a nice circle.
You like that, sir?
I like yours too. I was talking about mine
Why is there a hole in the middle?
We have a cavity.
So it's not a solid. So you
Yeah,
gotta
go
Well,
go
it's supposed to be with a cavity. Wait, do we put it what?
Yeah, what do you want?
precise wording, perhaps, for you to say what you mean, perhaps.
Whoa.
Harpoon gun?
Jesus.
That's all right. I control the grades.
Oh.
I once said this is pronounced as evenly distributed. Okay, so let's say we had radius R1 and R2. Okay. Everybody good so far? That part should be easy. Okay. And I'm going to put a Gaussian surface.
Must be nice to draw that with a big board.
By the way, this Gaussian surface will put at
Yeah, I just changed.
What is the electric field inside the Gaussian surface? Sphere?
Zero charge.
It's neutral.
Inside the Gaussian.
It hasn't passed through
The other thing is
anything.
there's no charge in here.
So it's zero. There's no charge.
So, equals zero, okay, we have it right. I didn't say we were wrong, okay. Looking at R less than R.
Stop writing in gold, John.
Okay.
I see green. I see purple.
Now we're gonna change the condition a little bit.
Supposed to write in
It didn't get larger, or
He's
more
writing
up.
white. Yeah, he's not writing. He's not writing anything.
Oh, that was the slant. Why, negative charge.
easy.
Just draw one
Just
more
draw
line.
one.
Now, we'll go, we'll go
Stop
with
shaking.
it.
I gotta move,
It's not
alright?
my original.
Can't sit
I was
still.
drawing a circle.
So, negative Q.
You can see the bottom part.
By the way, whether or not it's a negative Q or positive Q, I know in negative Q in theory, the line should be going inward versus positive Q going out. But you will find that when you do Gaussian law problems, even if there's a negative Q, you could assume the lines go outward all the time to simplify the calculation. You can make that assumption.
You just make a negative number.
You just change the sign in the calculation. Okay? So, just a bit. So we have a negative Q inside of it. What's that negative Q gonna do to this surface? What's it gonna do?
Charge.
Put a charge on it.
Put a charge on it. You think?
Oh, you have to put gas and circles.
That's what I've
Yeah,
learned.
that's a good point. We put a Gaussian surface here.
Solid.
I can draw dotted lines, but it's epic.
Let's say put the Gaussian surface there. What would be the charge and why on this surface? What is it and why? Yeah. I just want to know if it's positive. Don't give me negative. On this cavity, on this shell, this cavity, what would be the
Negative Q.
charge? and why?
Induction.
You're saying positive, John?
I think.
You are correct.
Good stuff.
Mr. CCO, do you have any emotion?
Next year, you'll be teaching it.
I'm not. Thank you.
Now, John, why?
Wait, what are those referring?
Positive charges on the surface.
On the surface of the outside, not the gas.
No, not the Gaussian.
Okay.
Okay. John, what was your rationale?
Because it's by induction.
You by induction?
You proved the case for n+1 if n is true.
Okay. Can you go a little bit further, what you mean by induction?
It's negative, so it's like pulling. It's the negative charge is pushing away the electrons in the sphere, and therefore it's left with a positive charge.
Everybody hear what he said?
Where are they pushing?
Where are they pushing?
Oh, the outside. The largest.
Now, that's one explanation. What's the other explanation of why it has to be positive?
Because if you look at the flux lines, they're all going in towards the center. When something is an object, it's positive.
So
So it's positive.
I'll give you a little clue, Jared. Look at where I drew the Gaussian surface. Why does the negative have to have a positive on the equation?
Because then they're looking to propel the gas.
No, don't go into
I don't know. I just was thinking like
Each other out so that the charge inside the Gaussian surface is zero.
Yes!
He's wrong.
That was right.
I think I was right too.
I don't think I followed it.
Pokey,
Repeat it,
a
gang.
Gaussian surface equals.
Alright, so the negative and the positive balance each other out so that the lines or the charge on the inside of the
Ah,
Gaussian.
can't write that fast.
He's too chill. He's
Need to bounce. Keep going. I'm just gonna write what you said.
Need to balance each other out so that the charge on the inside,
Not charge.
the flux do. You have inside of the Gaussian surface is zero.
Because within a Gaussian surface, it always has to be zero. So you have to have that negative and positive charge balance. What's the charge on the outer surface? On the actual this surface?
Negative Q.
Because it's going in.
And why is that?
So now we've dotted lines and.
That's, no, I'd say it's Gaussian, that's the actual surface. Why is it negative on the outside?
I'm still sticking.
Why is it negative on the outside?
That's where the electrons got pushed.
That's where the electrons got pushed. So if this was a negative 3Q, what would be the charge on the outer surface?
Negative 3Q.
Negative 3Q, which is justifying what? in terms of the query?
That the charge resides on the outer surface.
Is it as clear as mud yet? Want to give them the formula?
You skip right to the boxed formula.
What's what?
You skip right to the boxed formula.
There's no formula. This is, I have to give you an example.
So, is the inner one positive communication to
What do you think? Yes. Is it a what? Not the sphere itself.
So if there's like a second cast,
I was doing a clip yesterday with LBJ.
There's a sphere inside
does
the
it just
cast.
keep like flipping back and forth?
I don't want to,
just
I
went
don't want
outward
to
and
answer
outward.
that
Talks
because that's
about
going to
his
problem.
chance of greater than that's
That's-
and then he's like,
That's,
yeah,
that's,
he's
that's,
got
that's,
face
the
from the
side-
back from a
that's the
monkey.
side problem.
I assume it just keeps
Yeah,
flipping back and forth.
Yeah.
If you just put another ring around that, it would just be
Oh, yeah.
Yeah,
positive on the side
basically,
and negative on
basically
the
you have
outside.
jumping back and forth.
But it wouldn't lose charge, it'd still be 3Q, negative 3Q on the outside for the last ring.
Well,
Because you technically lose charge. because you went
well,
out.
let's look at it for a second. Let's look at it for a second. If I wanted to graph this, if I want to graph E versus R, okay,
This is gonna be a quiz question.
that's a pretty quick question.
It's gonna go down to negative x squared.
It's
Yeah.
basically going
Or-
to be flat for a little while.
Isn't it 1 over x?
It's going to be flat for a little while. Okay?
Absolutely.
You're going to be at 0 basically. Then it's going to jump up, then it's going to come down. Can anybody explain to me what this point is, what I should be labeling that for?
R1?
Critical velocity.
Oh, the E thing, epsilon.
No, not this.
It's a constant.
What are we doing?
Yeah,
I want
R1.
to know what this is.
R1.
Okay?
Well, because it's.
Because here you're where?
Inside the
Inside.
cavity.
You're inside the Gaussian surface, you're inside the cavity. Then you have this, and then it decreases, okay? Here's my question. What is the electric field measured out here? What's the equation for it?
KQ over R squared.
So here's the interpretation of that. If you had a solid sphere, the electric field is KQ over R squared. This was the question that you were asking. If I drew the Gaussian surface here, okay, actually, if I drew it here, Gaussian surface, it's KQ over R squared, which is saying what to you? That the electric field outside a sphere is the same as what?
Inside of point charge.
The same as being in a point charge. It really doesn't matter that that sphere is there. It's one and the same, because you just told me that if this is negative 3Q, this is negative 3Q. So what the hell does the sphere matter?
What if the sphere's an insulator?
No, we're not getting into that. We're not doing an insulator. This is conducting. We're not doing insulator. Okay?
The sphere would matter sometimes.
Yes. But the conditions set up here.
Okay.
Okay. So effectively, the field outside of the sphere is the same as that if you were at a point charge. Make sense? Okay.
I see gold, I see
Now,
white.
let me tell you something. Let me tell you something. Classically on an AP physics test, what they'll do is they'll say to you, they'll give you a diagram like this, and they'll say, oh, we have this sphere, and blah, 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 and then they'll ask you to write formulas down and basically get, and if you look at the one on your assigned homework, it's actually from a calculus, they ask you to get to here. What I'm doing for you in these notes is giving you every classic symmetry case. So whatever problem you would get on the test, or whatever problem you would see in college, you're going to have a strategy to go, yes, I can use that symmetry, and that's going to give me the answer. You will not find these notes anywhere, but that's the purpose of doing this. How are we on time?
not enough.
Let's see how. Huh?
We can talk about that.
Said not enough.
I'm blue.
I'm blue. I think you're legally dead. Okay. All right. Anything else I have to say about this? No. Okay.
And we're done.
Let's see if you truly understand this.
Oh, that's a dangerous statement to make.
I'm going to work with this now. On the electric field of a uniform ball of charge. Radius R and charge Q.
Is that a positive Q?
Yeah, positive. As the function of R from the center of the ball. By the way, a ball of charge is not a solid sphere of charge. Don't make that joke. Please, reorganization notes at the last things. I'm going to use it. So we have this ball of charge, magical ball of charge.
That's not a sphere.
Huh?
Not a sphere.
It's not a sphere. It's spherically shaped.
Okay.
It's a spherical
But
shaped.
it's equivalent
ball
to, we
of
can assume
charge.
it's a point charge, correct, or no?
It's a spherical ball of charge, evenly distributed. Think of it as an electron cloud.
Oh, because I know what those are.
That makes sense.
Yeah, it's a spherical electron cloud. That's a good image to keep.
of a ball.
It's a equally distributed spherical ball of charge. Q. I'm sorry, I can't do.
Okay.
Happy class.
I got
So-
you. It's not a charge in a sphere. It's
As
just
Right,
a
it's an
charge
even
as a
distribution of spherical charge within a spherical area.
As we increase the radius, we increase the enclosed charge.
There's charge. There's
Are you talking about it in terms of the Gaussian surface?
Yeah.
Well, yeah, we're gonna get there. So we have electric field lines coming out in all directions because we have this equal distribution of ball of charge. Okay. All right. So what do we want to do? Well, we want to put a Gaussian surface there. And based upon symmetry, what type of Gaussian surface would you like to put?
Point
The
charge.
sphere would be nice.
There's no cavity there.
The sphere would be nice. So we're going to put a Gaussian surface that's a sphere around that, okay? And because it's uniform and everything else, and everything's nice and kosher and everything else like that. Kosher? It's a little Yiddish. Okay, we're going to put R less than or equal to R. In other words, we're going to keep our Gaussian surface within the ball of charge, okay? So we know that the electric flux is going to equal the surface integral of E dot dA, which is going to equal to Q enclosed over epsilon sub 0. Good so far? Okay. So you know we can say what?
E equals K Q R squared.
Well, we know that E 4 pi R squared is going to equal Q enclosed over epsilon sub 0.
You have to do this every time. Is
Yeah.
that like as far as you're going?
No, we're going to go further. Okay. We're gonna go further. All right. Here's where it's going to get interesting. How would you relate the volume of the Gaussian surface to the volume of the entire ball of charge? How do you think the volumes relate?
It's proportional somehow to the proportion of the radii.
Don't give it to me proportional to the radius right now.
What other measurement do we have?
You do have something else. This is the way I asked the question. I asked the question, how can you relate the volumes of the charge flow, volume of the Gaussian surface and the volume of the enclosed, the volume of the charge, the ball of charge?
Q should increase by a cubic
I'll
function.
give you a little hint. What is that related to?
V over V.
Huh?
The volume of one over the volume of the other.
What volume of what one over the volume of what other one?
The volume of the Gaussian surface over the volume of the sphere.
Everybody agree with me saying? Okay. So there's a relationship between the volume of the Gaussian surface over the volume of the entire ball of charge. What is the volume of the, I don't know what the question is for the volume. What is the volume? Everybody remember?
4/3 pi r cubed.
Okay. So we have 4/3 pi r cubed, and the volume of the ball of charge is 4/3 pi big R cubed.
Which simplifies the r cubed over r cubed.
Can somebody give me a formula that puts that a lot simpler?
R cubed over R cubed.
Times Q.
Which R cubed? Which R cubed? Little
A
r.
little
big
over
R?
big.
That goes to R cubed over big R cubed times Q. Everybody good? Yes, no, maybe? Solve for E. Remember, that's that. By the way, this is not what's given in your physics book.
Good thing I never look at it. It might confuse me.
I don't know why they don't explain that in the physics book. They don't talk about the relationship to the volume. Anybody get it yet?
KQR over big R cubed.
Okay, say it again.
KQ little r over big R cubed.
Have to think about what you're saying. Say it again.
KQ little r all over capital R cubed.
Is everybody getting it?
Combine the epsilon to make K.
Everybody good?
Yeah, 4 pi gets,
The boot.
yeah, because epsilon is 1 over 4 pi k.
Say it again, Jason. So I'm sure you said it right.
There's a capital R cubed in the denominator and a lowercase r, no exponent in the numerator.
Basically that. It's a box.
Do we get this on the formula sheet?
Maybe. They also sometimes write it like this, so you know. They leave the epsilon sub 0 in.
That's done.
I'm just giving it to you. Just so if you see it, you recognize it. Okay.
You recognize that they're done.
Now, you all should be able to answer this question in less than 30 seconds.
Yes.
This is far as less than this. How about if it's greater?
Gaussian surface of
K equals KQ over R. Squared.
Yeah!
Nice.
You're getting it.
Now, would that be R from the center of the ball?
Yes, all R's always for the center. You're getting it. They can be so happy. Okay. All right, we'll stop there. Monday we'll do some example problems, and then that will be the logical break. After you come back from the senior class trip, we will pick up with cylindrical symmetry, flat surface symmetry. And I will go out myself publicly in front of